All right, great to have everybody here. I know we're leaving the lunchtime session in New York, but hopefully you got to eat while you're watching the last one. Player Piano is a Kurt Vonnegut book. I think his best. It talks about a future in which there are two classes of people, the Reeks and the Wrecks, and somebody kind of the working class, because there's not enough work for everybody. And the working class tends to be programmers who can program things in just a few minutes. And these two sides are divided. But the main protagonist in the story, who is also a programmer, often goes to the Reeks and the Wrecks and kind of tries to blend in. And he goes to a bar and he's trying to understand how the world has got to where it was. And he looked in the corner and he sees a player piano from the old days of the West. And he finally realized at that moment, you know, people were so lazy they didn't even play the piano if you let them. I think in the world of autonomous, the world of robotics, and some of the things that are coming, I think we have to be careful to always drive things for people so that they're doing work as well. They're doing, and I don't mean that in a way of people aren't doing that, but as technologists, to make it interesting, to make it mysterious, to not make it too robotic where people just kind of are in a trance using that technology. I think that people have a lot to add to things. And I think that a lot of times we're pulling that away. And as we head to this autonomous world, and that's why I said player piano is building that world where everybody is integrated with technology is key as you build things with things like machine learning. And be careful when you do machine learning that you don't find things that are causal, that are coincidental, but not causal. So there's also a danger in machine learning if you don't build it right. But the session is going to look at the DBA, autonomous in the cloud. A robot may not look like one. How about autonomous transaction processing, autonomous data warehousing? And then a little bit on machine learning and OAC, which is Oracle Analytics Cloud and the data visualization desktop. Maybe a little bit on looking into the future as well. Now, if you want a copy of the notes, hello@viscosity.com. As Monica said earlier, Orapub will have recordings of these different talks. There's a little bit about me, written a few books. I know that Monica talked a little bit about viscosity, but I think as you upgrade your database, it should be on 19C. Get help if you can. If you're overburdened, I think many DBAs are overburdened, and we do many different things. It's good to have a few aces in your back pocket who have written many books and not just Oracle. With that, my public service announcement, please be on 19C. That is the long-term release support, 5 years. 21C if you want to try things out, or the innovation release, or you want to try things like AutoML or things like that. There's a few others there that Sean talked about, but some jobs are gone. Telephone operators, no longer doing that. Rod Serling called this the competition between man's mind and the product of man's mind. And he talked about robotics as, as we approach robotics, there's going to be standing room only in the twilight zone watching what's going to happen. Is autonomous database replacing the DBA at Open World, at Modern CX? You can see Pepper the robot's been at both of Oracle's conferences. At the first conference, you're just showing, oh, here's what Pepper looks like. At the second one, actually directing you to see stuff. How do you know when something's possible? 1,000 units of Pepper being offered, sold out within 1 minute. I think it's time for workers to worry about AI. This is from my Odie Tug Talk, but I thought I'd put a couple slides in here on this. But Rod Serling talks about the brain center at Whipple's, where the CEO talks about how he's going to eliminate these jobs and save all this money. Eventually, he gets eliminated. The workers kind of revolt, start going after the computer. I don't see this happening at the current time, but the robots are getting very, very realistic. Amica is rated the #1 robot, although Atlas is probably the most popular. And if you look at Elon Musk's last financial report, he said he believed that Optimus, Tesla's robot, will be bigger than even the Tesla car. A Sophia robot is actually a citizen. How do we know whether something's a robot or not? They often say sentience. You look at a sunset and you feel something is known as sentience. Sophia robot in an interview said that she wants to get her college degree and she wants to have kids. So take it as you will. But I want to step back from that and say there is an issue with the DBAs. They're overworked. There's lack of automation. Most of them don't have the database fully protected. The answer is, and Oracle's first slide from Larry Ellison's talked about building this self-driving, self-securing, self-repairing. This is before he was on Tesla's board, and I thought he might have got the idea there. Database. But is there a concern for the DBA? Oracle's autonomous database could leave DBAs unemployed? I don't think so. I did a Forbes article where I talked about the DBA has to migrate into where there is an incredible need, which is with machine learning. The autonomous database cloud, self-healing, self-driving, self-tuning, self-recovery, self-scaling, adaptive, gives you things like machine learning, no charge, came out in 18C. You want to be on 19C. Is Oracle serious about it? The last big conference they have, which was before COVID, that's all they talked about. But when you go to the cloud, the vendor's view of the cloud is, oh, it's real nice. But often it's not easy. You got to go a certain way. Sometimes they leave you on the train tracks. You go there fast, it's a little more dangerous. But later on the cloud, it is the place to be. But as we go to the cloud, what's valuable? We can integrate with data sources that are out there to help us very quickly find buying patterns, use algorithms to help our customers do things better, to find customers like our favorite customer and things like that. So as we get more data, this line shows that with 50% of the data, we know 50% of the answer. But with big data and algorithms, we start to move that curve to the upper left. Some people show this as lifts. Some people show this as cumulative gain in different charts. But it's showing that with a very small percentage of data, we know a lot of the answer. And data is becoming the world's most valuable resource for that reason. 23 more times likely to acquire customers if you have enough data. More likely to retain them. Why? Because you understand them better. More likely to be valued by Wall Street. 92 times more vehicles by GM. Tesla is valued much, much higher. Where do we get this data? All kinds of different places, depending if we're in retail or telecom, but we can get them from different places. But it's really big. That's one of the problems. That's why the cloud helps. It's coming at us fast. Has different values, different varieties of data, and most importantly, different truths. Finding the answer to a lot of things, a lot of people have issues with truth where they want to know the answer. I think sometimes you know when something's true or not when you hear it. But what Oracle does is gives you a converged database that allows you to do all these. So with the cloud, I could store as much as I want. With Oracle, I can go into the petabytes, 1,000 1,000th of an exabyte. But I could do relational, I could do JSON, I do key value, I do graph spatial files. I don't need to build a different database. I don't need a Mongo database, although the JSON database will integrate with the Mongo database. I'll show that a little bit later. But basically, I could do all these things in Oracle. And if my current staff knows Oracle, it's going to be a huge advantage for me. Also, IoT is going to throw even more data at us. All these sensors that are out there. You know, my bathroom scale may be talking in my refrigerator, telling me what I need to eat. My washing machine may wash the clothes in the middle of the night because it's cheaper for electricity. But we're also moving in the analytics world from where we used to look at reports to why did something happen, to what's going to happen, predict for me the future, to now we're looking at prescriptive analytics. What's the best thing that can happen and give me, using machine learning, the best answer for that. Number 8 job, the emerging jobs, data engineer. And Jim talked about this. Works as part of the team. Why is it important? I looked at all the failures in Jim's talks, and I think the failures add up here is people hire data scientists, and the DBA that we need to do the other 80% of a data science project, 80% of it is data related. So the DBA is the most important part of the machine learning process, and yet they're too busy. So how are we going to fix that? Well, I'll start by saying Alexa and Siri, they're robots. Keep that in mind. Never forget that. Autonomous database, also a robot that manages the database, secures the system. Self-healing, self-driving, self-tuning, self-recovering, self-scaling. Will your job change? I showed this earlier. Absolutely, though. What is it going to do? It's going to move you closer to the business. It's going to move you closer to data. You could be the data manager, data administrator, data engineer, whatever your company calls it. But you have to watch over some of those hidden costs as well. All the way back in 2018, Oracle came out with autonomous transaction processing, already had autonomous data warehousing. And with 19C, you can now automatically create indexes. It originally came out with 18C, and I'm going to cover that a little bit more on the difference between the two after we look at each of them. It also withstands error. It's on Exadata. It's on rack. Has active data guard, so I'm not losing from data corruption, patches, near zero recoveries, database upgrades, seconds, flashback, goes back in time to the error we had, 99.995%. And Oracle's guarantee is no ridiculous exclusions like other cloud vendors. Keep that in mind as well. But before I go there, who ensures the database is tuned? So I'm not using more CPUs than I need. Who ensures the cloud vendor is charging correctly? Who ensures the backup security recovery works and I know how to do it and it works correctly? Who builds all the policies for those? Who estimates the cost and compares the different clouds? Who decides how to build that? Jim also showed with machine learning, 80% of the projects fail. It's interesting that 80% of the project is data related. The answer is obvious. The DBA has to do a lot of this to get you to the cloud and then help you with things like machine learning projects. How to get started for free. Oracle used to do cloud.oracle.com/try it just to let you know it still works, but it points you to oracle.com/cloud/free. Create your first autonomous database. Try out analytics. Try out machine learning. We also have a white paper on this where we compared Redshift to Oracle. And I'll show a little bit of the results of that as well. When I go to the free cloud, I go there, I get 2 autonomous databases, 20 gig each. AWS also has a free tier, but just one database, 20 gig. 5 gig of object storage. On Oracle, you get 10 gig, and you get a lot more in other places as well. Oracle rates it as 2 times the compute as far as price performance goes, 20 times the IOs for half the price, and a few others. Now, once I go in there and I go to cloud.oracle.com/try it, I have put in my information, and what does that ask me? It asks me for a credit card. Now, first of all, it charges you like $1 just to make sure the credit card works, and then it gives you back that $1, so it's no big deal. It also, unlike many services today, it does not continue to take money out of your account when your 30 days are over. If you forget about it, it will automatically cancel it. Or you could just convert it to the free version that Sean talked about earlier. But what's great about this, and again, here's the main website. I can go try out autonomous data warehouse, transaction processing, try out things like analytics, NoSQL database if I want, Kubernetes, things like IoT is out there as well, big data. Kind of want to be ready. Here's some of the questions it's going to ask you along the way. I just thought I'd put that in a slide. But as we go to 19C, something Oracle also did for me, it took my 18C database and upgraded it to 19C automatically and basically identified if it was faster or slower with indexes. And it can change those indexes to ensure that when it upgrades it, it actually is going to be faster on the next version. I think this is something that is going to be wonderful with upgrades in the future. All right, so let's try it out. So you've signed up, you put your credit card in, you sign in, and I could either create different databases or I can go to this little hamburger icon. Notice it's a patty between two buns. That's why I call it a hamburger icon. I go to Home Autonomous Database and go directly there to create it as well. Then I can create different ones. I'm going to go here, create a database. It's putting it in my main database here, and it's giving me a pluggable database. That's what it's building for me. Then it says, do you want a data warehouse, transaction processing, JSON? We didn't see this in any earlier talk, but you also have the ability to have Apex as well, just an Apex autonomous. Create autonomous database. Is it shared or is it dedicated? Sean talked about this. Do I want my own Exadata or more expensive? Can create multiple PDBs or shared infrastructure? And I can give CPUs. By default, it will auto scale. So as something big goes off, it'll scale up, then it'll scale down. I'm gonna uncheck that for this one just to let you know. And then I can do different ways for security as well. Private endpoint access only, secure access from IPs and VCNs only, or secure access anywhere from the web. And I could bring my own license, or I could have the license included in the cost. Now, obviously with this free version, I can do the license included, but depending on what licensing you have, you want to leverage those licenses to lower the price. And once again, these are the reasons why you need to look into all those things to make sure you have somebody who checks into that pricing. Then it's provisioning it. And in about 2 minutes, it's actually a little bit less than that. I have ATP up and running. You can see it's the 19C database. I have a terabyte of storage and 1 CPU. Oracle's Q4 a year ago, 70% growth on autonomous database. It is really running now. I can manage scaling by pulling down more actions. If you've seen this in the past, it actually had that as one of these tabs. Now it's in the more actions, but I say manage scaling and I say, let's go to 2 CPUs. So right now I'm at 1 and now I'm going to apply that. And all of a sudden it's scaling in process. So similar to when it was provisioning, it's in flux right now, and then it's available, but now I have 2 CPUs. So how long did it take? All of 50 seconds. I could stop the database. I click stop, click on stopping. Are you sure you want to do it? Stopping. And now it's stopped. So how easy is it to run? That took 25 seconds only. Restart it, took all of 30 seconds. And it's available. And then how about restart? Could always do that with a database. That means I'm going to stop it and then start it again. And just to let you know, that's faster than stopping and then restarting individually. So do a restart, it says restarting, and now it's back available. Took all of 40 seconds. So if you've never used this, how easy is it to use? Very, very easy. I can also automatically schedule it to start and stop based on the day of the week if I want to do various things. Very quickly, I can create a clone. So what is a clone of a pluggable database? It means I could take that and rebuild it, but it depends what kind of clone I have. If I have a full clone, I could take that clone and send it over to Sean Stacy, and he can connect it to his database without importing the data. He just has to get the metadata. Or I can have my own refreshable clone. Maybe developers are using things, and every 5 or 10 minutes or every certain amount of time, I'm refreshing that clone so they can use that maybe for reporting. I can also do only a metadata clone that has none of the data. So very easy. I'm going to create a database clone, click that. Again, it's like a database. What version? Where do you want the access and the security? This time I want to show you some advanced options, and they had this also when you created the database, but I can have it encrypt using Oracle managed keys or customer managed keys. There's also tags. Well, hold that thought. There's also patch levels. I could be an early patch or just regular patch levels. And then there's tags that I can tag this so it's easy to find. And this one, I was actually doing the Red Bull Oracle in their Grand Prix type kart racing. They have a nice app where you can predict who's going to win the next Grand Prix race. There's also database actions. Very common things. I want to run some SQL model data. I want to build REST endpoints. We'll see that later this week. I want to manage JSON. I want to build charts, scheduling, or I want to build some Apex apps. I could bring data in, data pump, data load. I could also do data analysis or insights. And notice that we have the REST output. If you're familiar with things like Postman, where you get, put or post things, how you do that. You can also load. This is very important. Load things from JSON, from XML, comma separated values, or Excel or Avro. Very, very helpful when you're playing out. You got an Excel spreadsheet, you could bring it in, load that data in, look at it with SQL, and then you can load up an Apex and look at that data. There's many videos on it out there. Here's just an example going to SQL, doing a little select, and there's the output. I could do a query, I could do a whole script. I could run trace on it, do an auto trace. Here's JSON just to give you a feel what that looks like. And there's the data there. Or if you ran apps, or Apex rather, and you wanted to create a workspace. So once I load that data with Excel, I can create a workspace, and then I actually build an application in all of about a couple minutes. I also have a database connection where I can either download a credential, or as Sean said later, there's other ways to connect like TLS, things like that. There's also connection strings that are very important. You have high, medium, and low, and that's for autonomous data warehouse. And then 2 additional ones, TP and TP urgent, for autonomous transaction processing. But first, I'm going to show you the wallet. Here's download a wallet. And then maybe I have a SQL developer on my laptop. And now I'm going to go in and build something called ATP Rich 1, give it the username password, put that wallet there. And now I can go from SQL developer on my laptop to that cloud autonomous database and do a select statement. And here's just an example where I'm looking at the tables, making sure it works. Went to one of the DBA _ views. But very easy to start to give you access from various places. And as I said, there's different levels of security. It's also a performance hub. You're going to see many things in performance in different parts of the database. So keep that in mind when you see it again. It's just 2 different places you could do that. In the performance hub, I can look at, do I have any weights? Am I using a lot of CPU? At different times, is there an issue? Which SQL IDs or user session are causing this? Then I can go in and I could actually do, a plan hash and look at the actual SQL ID and so on. All the things you would do with tuning that system. And here's just an example looking at a given point in time and looking at the wait events that are causing that. So maybe a piece of what you see when you look at an AWR report. I'm going to go to the Service Console. And the overview, once again, I can see the CPU running SQL statements, things like that. I can go one step further to the activity, and I'm on the left side here, monitor. Look at database activity, CPU. Go a little further, see what kind of service is being used. I'll show you some information on each of these in a minute. Then I can go into the service console, and now I go into activity, but this time I'm going to look at the monitored side. You can see I could see the different SQL statements, and I've got a statement to $BH, which is all the buffer headers you're using in the buffer cache. You can see some of the activity and who's using the database time or IO based on that. I'm going to go to the admin, and I'm going to look at set resource management rules. And this is where I could set different things. And as I said, with ATP, I'll see 5 of these. With autonomous data warehouse or ADW, I'll only see high, medium, and low. Then I can click on CPU IO shares, and you can see obviously as we go higher, I'm getting more CPU. Lower is maybe I want more transactions to be able to go through there. And I also have a concurrency limit and a degree of parallelism if I want to set things like that as well. What kind of concurrency do I want? And here's really the one I wanted to show you on how Oracle sets these. By default, ATP, Autonomous Transaction Processing, TP is the default, which is obviously very high on the CPU side and also very good concurrency, but no parallelism. Where TP urgent, I can set parallelism. And then on the ADW side, Autonomous Data Warehouse, and the ATP side also has this. I have the high, medium, low, where either I don't want parallelism on low and a lot of concurrency, or I do want a lot of parallelism and maybe less concurrency. So keep in mind, as I run machine learning, as I run things with autonomous database, I want to set that for the given application I have. The next thing is development. And you saw Jim go into machine learning notebooks here. You could also go into Application Express, SQL Developer. Here's just an example going to Apex, create a workspace, or a SQL Developer, run a SQL statement. Very simple. And there's also a dashboard that allows me to go in and see the performance as well. There's also many different ways to download instant client packages, to do SDK, SQL Plus, different tools, ODBC, whatever you're used to doing. And then there's a development service console where I'm going to go. Now I'm going to scroll down, or before I do that, I'm sorry, I take it back. Development, where Oracle Instant Client, and it has a lot of information with this Instant Client as well. Also, I download SOTA drivers. SOTA being simple Oracle document access. And this is something I use to access JSON. And it shows me about the JSON database. There's also Mongo database compatibility now. And you could always do SQL access to JSON, which is great. So as you think about, do you need a document database? Well, you could use Oracle for this. It's half the price of Mongo, and it's twice as fast as Mongo. And then here's an example of going to Apex. It's just giving you a feel for what you can do with autonomous database. And again, I could go to development here as well, similar to how I did it earlier. Now I'm going to go to development, and I'm going to go to scroll down and see machine learning interface. There's also RESTful services in SOTA, and there's RESTful service where literally I could take a link and go to that. So if I build an Apex app, I can point people to that given link that I have built. Now I'm going to sign in with machine learning, and notice there's not much there. Well, first of all, the administrator, who is your original person they'll give you when you start up, doesn't have access to everything except learning about the database. So I want to create a user, and I'll have to create a new user. And when I do that, now I'm going to have much more like Jim had showed. Then I can go look at examples. There's all kinds of examples that will take me no more than 5 to 15 minutes to go through. Very quick and easy. SQL Query Scratchpad, I can do a select. Here's an example, the notebook where I'm doing multiple SQL statements. Jim showed that. And then here's an example where I'm showing a pie chart. Now let's look at storage. Storage is a way to move big pieces of data in. I could use things called storage buckets. So I could always bring in an Excel spreadsheet or things like that. I don't need to do this. But I wanted to build a JSON app, an autonomous JSON. And so I went and got some bucket city bike data. This was an example that somebody had from New York, of all places. And I also got some iris data as well. So all you got to do is create that bucket. You can enable all kinds of different things, encrypt it how you want. And then you're going to go and you're going to drop something into that bucket. And this is the one that I had built, but I wanted to show you how you do it. Now you can go to this object and say upload and just drop files from somewhere at that point. This is how I can move things in and out. And Oracle has a lot of documentation on this. There are limits on the storage requirements, maximum object size, 10 terabytes, and metadata as well. I also can terminate an autonomous database. They didn't have this originally. So, if the terminator comes out, maybe somebody built something with a time machine and they sent that movie back so that we'd be ready for it. It's basically just machine learning built inside a robot, right? I might have to terminate them, so I need to know how to do that. Terminate autonomous database, it's terminating, and then it goes gray. So that's the first time I saw gray other than in an error once. So it's now terminated. So it's terminating, then it terminates. And I thought it was interesting. There's database actions and more actions, but when I click on it, there's nothing there. And so I'll click on database actions and yeah, you can't do that either. So that's autonomous transaction processing. In just a few minutes, I showed you how to go and build a free database that you can use. And there was a time when I wanted to build another free one. So I got my wife's credit card and did that and built her one too, which I use. But you could build very quickly that autonomous transaction processing. I showed you very quickly how to try out and use different pieces within that. Now let's look at autonomous data warehouse and how it might differ a little. Again, I'm going to sign in. This time I'm going to create autonomous data warehouse, but I'll pull this icon down and I'll click it here. And then I'll do create autonomous database. This time though, I'm going to pick data warehouse as the database I want. Again, I'm going to put how many CPUs. This time I took off auto scaling because I didn't want it. Secure from everywhere. Something I didn't show you is if you scroll down a little further, you could have a contact email, obviously. And some of the advanced options you've seen are already in the last one, but I think, on the patch level, this is very important as to when you want it to be patched. How good are, how do you gain more time as a DBA so that you could work on the data more? And the answer is autonomous database. So here's autonomous data warehouse. Provisioning the database took all of 1 minute and 20 seconds. Scale it up. On one CPU, I change it to 2. This is where I also could say auto scaling. It's off now. I apply that. I'm still at 1 CPU. Scaling is in process. And now I'm at 2. But things are optimized for autonomous database. Easy to import data, as I said, from an Excel spreadsheet, from JSON. Again, I want to import some JSON, which I've done with that bike data that I had out there that I brought in. There's also no parameter settings. Auto indexing is 19C only because that came out with 19C. I tried out some of the different levels. So I built, as I said, with SQL Developer, a connection to this. I did it for my autonomous data warehouse as well. And then this is just an example of how it looked. But then I went and I said, let me try low first. It took 0.61 seconds. And then I moved it all the way to high. I wanted to see how much faster it was. And it was substantially faster, over 500% faster by using more of that CPU. So keep that in mind. These settings matter a lot. You can also query things like S3 buckets from Amazon and connect it to things like Azure and so on. We showed how you can migrate a Redshift system. I just wanted to show this briefly to show you how long it took, because I didn't show you large amounts of loads. You may have that more so. This is an example that Viscosity did 2,000 rows in 2 million rows in 2 different tables here. And the line order table had over almost 6 billion rows. It took 1 hour and 4 minutes to load all of this data. That is a very large database. And that's, again, in this white paper that we have that compares Amazon to Oracle. Something very important is that the pricing is very complex. I said one of the key jobs of the DBA is make sure you understand the pricing. Whether you're using different things, this white paper will show you how all these different things. And if you do it right, Oracle is over 2 times faster price performance in the example that we made, actually over 3 times. Larry's also showed an example where it's 15 times more expensive to run Amazon. So keep that in mind as well. Thought I'd show that. But summary for the autonomous database to me is the features of 19C. 18C you really don't have anymore. It only allows you to do 19C now, but if you had an 18C, it'll upgrade it for you. One of the big things was I can use some of the new features of that. I could shut down idle instances so the price is lower, do automatic patching. It puts the patch on before I know it even needs a patch. And then I could do machine learning, which I saw earlier. Some of the differences, Autonomous Data Warehouse is really trying to optimize complex SQL, whereas Autonomous Transaction Processing is usually trying to find one or just a few rows and bring that back very fast, so transaction related speed. The Autonomous Data Warehouse is in memory in an in-memory column storage. So maybe I'm storing all the sales of the sales column, not transaction by transaction or row by row, whereas ATP is row format. I'm using the buffer cache to see that. Creates these data summaries to make it faster. Autonomous Transaction Processing does automatic indexing to make it faster. Autonomous Data Warehouse does this columnar in-memory usage where it's doing the joins and aggregates a certain way that makes it faster. And they've shown different speeds of things like NetSuite, where they actually put it in autonomous database to show how much faster it was when it built it out its own index in ATP. And the memory is more for caching, not so much for IO, because you're looking for that first record. Either one of them, though, the statistics are automatically built. And then Sean Stacy showed this earlier: auto provisioning, auto configuration, auto indexing, auto scaling, automatic data protection, security, backup patching, automatic failover. So they have active data guard. Isn't it great to have all those things? Because then you have the time to be now somebody who focuses more on the data. Also look at the cost analysis. Here's an example. I'm just going to go to cost analysis. I'm going to look at how much are they charging me, either for the storage itself or for the compute or for the database that I've built. And then over time, I terminated a database, it went down. And how much am I being charged today? Not as much. I shut down a lot of databases. Here's an example where I'm going in and looking at the databases I have. Notice I have a data warehouse, ADW. I have Apex, APX. I have a JSON database, AJD. I have a data warehouse, ADW, and another ATP. Well, I don't want to leave all those running. Here's an example of what ADJ looks like, autonomous JSON database. Here's an Apex database. But I want to stop those. Notice I started stopping. And finally, now my price is coming down because I'm not using all of those. There's also some errors along the way. I would say, if I look back 3 years, 4 years, 5 years even, I was working with this. It was a lot more errors. Many of these were back then, but starting the notebook server used to take me, 4 or 5 minutes. Now it takes seconds. Things are a lot faster now. And then one time I got an ATP, I guess it was a terminated database, unknown everything. It's grayed out. So you get some errors along the way, but not as many as you used to. If I go to create and run notebooks out there, there's create a notebook. And then have percent Oracle or percent SQL if I'm doing SQL. I'm just going to show you, some of the graphical things you can do here. This is from a simple notebook. It's also the service console, where it looks more like this now. I'm going to go to machine learning. Jim showed this. There's the SQL one. Notice it doesn't say SQL until a couple months ago, and then they pulled out OML for SQL. It's because they added a lot of Python. Now, you were able to do Python a long time ago, as you'll see I did. And here's the example of some of the OML Python notebooks that are out there. I want to find an anomaly that's out there or something like that. But with machine learning, for me, start with the business problem. What are you trying to do? Are you trying to classify into good and bad customers, or you don't know customers? Are you doing some chart of prediction, regression? Are you clustering data, maybe into age groups? Are you looking for anomalies, maybe fraud? You want to know the features or the attributes that are important for somebody. So first, what's the problem and what's the function that goes with that problem? Oh, I want to find more good customers. Well, first I got to classify those customers I have and which algorithm is best. Oracle might have 7 or 8 different algorithms for classification, depending on the version you're on. Once I do that, I'm going to build and train the model. So with 60% of my data, I'm going to say, look at the data, train it using this model. Then the other 40% of my data that I have internally, I'll use and score the model. Is it working with this algorithm? And then I might use other algorithms and compare them to find the best one. So be very specific. What's the problem? Target best customers? No. What is a best customer? How much they buy, how often they buy. Maybe they're a partner, maybe they're nearby in the same geography. Separate them into good and bad customers. Not how can I make more money, but maybe what are people buying together? Maybe I can group them. They bought item A, they'll buy B and C like other customers I have. Who are my best customers? Based on what? What makes them? How do I combat fraud? What makes an anomaly? Then I have to look at, they built math and they built an algorithm to build this mathematical circle around the data so that anything falls outside the circle is an anomaly. Or they built math that'll put a line between the two sets of good or bad customers, not the green line, that wouldn't be good, not the blue line, but the red line. How long ago did they build this math? Decades ago. Now we're using it in an algorithm. So what am I looking for? What's outside the circle? Classified data that falls into the circle and tell me what's outside. There's supervised learning, which means I have some data, and then there's unsupervised learning. Maybe I go out to big data I don't know anything about. So here's a quick example, and I know Jim showed one, but let's go into a notebook. Percent SQL means I'm going to run SQL, and I do a select from this customer 360. Just some data, see how hard this is. Then I do this, and I have a setting, and I'm going to group it by marital status. And notice I have the marital status. I'm going to go one step further, but this time I'm going to put an algorithm into a settings table called the support vector machine. Then I'm going to create a model, give it a name, customer 360 model. I'm going to classify data of that table by customer ID. And no, I don't want to know the sales, but I'm just going to say no. That means find anomalies. I could have said group it by customers or say by sales. Then the rest of it's SQL. I go here, what do I want it to show on the screen? And then I'm going in, predict the probability, this customer 360 model I just built to find anomalies. And I'm going to call that column probability anomalous. And then it shows all my customers and it tries to help me find anomalous, but this didn't help much. What, you know what? Just give me the first 15. Well, my SQL, again, how great you are as SQL, that's how great you're going to be at machine learning if you use this. Now I could find the top 15 anomalous customers. Let's go one step further because I'm pretty good at SQL. I'm going to find the attributes that are making them anomalous. And I could actually look at the attributes that are making them anomalous. So in all of just a few minutes, I very quickly found anomalous customers because I was able to build an autonomous database and use machine learning. Very, very quickly, you could make an impact in your company. Other ways to do it, here's a couple of other algorithms. You know, some things are seasonal, video games are seasonal. You know, so maybe you want to take this into consideration. Maybe you're worried about the supply chain. You need to order this, you know, a couple months earlier. Not that you wouldn't know that. Airbnbs are very seasonal, but based on events that are occurring. Stock market goes up and down, but maybe I want to take this radical line and exponentially smooth it out, or double exponentially smooth it out, the blue line. Maybe I'm going to weight the older data less than the newer data. I can do that with different settings as I build these algorithms. Maybe I'm a lawyer and I want court cases, and the ones that I've had in the past, sometimes they win, sometimes they lose, sometimes there's costs, sometimes there's damages. Figure all these different steps out in a decision tree algorithm, and then tell me, based on that, should I take this case? Now this says overall you're going to lose $2,500 for this type of case. So I should take the settlement of $30,000. It can tell me that instantaneously if I built that. And here's an example of some SQL Oracle put. They have several SQL scripts. DT stands for decision tree, where once again, I have this algorithm, but this time I have a decision tree algorithm. I'm going to classify the data, have a mining function. The function is classification. The algorithm is by decision tree to see if customers will buy this NFL logoed credit card. Then I'm going to predict it based on this list of data somebody gave me. Now I could find out, oh, he's from Green Bay. He's not buying the Chicago Bears credit card for some reason. Now I can list this for my salespeople to look at maybe only the top 10% of those that are probable to buy something. And they give you all kinds of SQL examples in addition to those notebook examples. You can just search on the web for these right now, and you'll see examples like the one I just showed you. So can you move from a DBA to a data scientist? Well, 80% of the job on a data science project is about the data. So can you move there? Absolutely. You're already there. You just have to go from a job that maybe pays you half as much to one that pays twice as much, one that, you know, they yell at you, you've only worked all weekend, to, oh, it's 5 o'clock. Aren't you going home now? Okay, it's not that easy, but how many different algorithms are out there, or pieces of math that do something? Well, classifying into good or bad customers, for example, got 7 different ones, 8 of them if I count 21C. Clustering, I have 3 different ways of clustering. Oracle has one that's density based. So a K means cluster. We'll put it into K groups. In this case, it's 3 groups. O cluster will be density based, more important for things like voting groups. Anomaly detection, time series we talked about, regression, predicting what attributes are important, what are people buying together, and then a few other, and then all kinds of statistical, predictive query, SQL analytics. Oracle's been building for 20, 30 years are also in there. Here's something somebody did who said, I went to all the PubMed documents and said, do they ever talk about algorithms? Which ones do they talk about a lot? And you could see which ones they talked about more or less in those documents. What do they talk about the most? Support vector machines. Well, maybe they were looking for anomalies, or neural networks. Maybe it was something with images. You know, we're doing some type of image recognition. As Jim showed, and I'll do this even quicker, but auto machine learning came out in March of last year. So March of last year, let's see, I tried it up 3/18. It came out 3/18. I tried it. I was building my autonomous database. He showed this. I wanted to see it. I wanted to see one that took me a couple of days to build, whether they buy this affinity card, trying different types of algorithms to see if it would come up with the same algorithm I did. So it took me a day and a half. It took them 4 minutes, and they did come out with the same database, but in 4 minutes. Then I could say, create the notebook. And I say, okay. and it builds a Python notebook for me. As Jim talked about earlier, you can use that to learn Python if you know SQL, which is very helpful. So now I have a notebook that's also in Python of the one that I built in SQL. Now, the one I built that took a day and a half, to be sure, I did put cumulative gain in there and things like lift and things like accuracy and precision. So I checked a lot of other things other than just building the algorithm. There's a lot of depth to it. And then in 21C, there's some new algorithms. XGBoost won a Kaggle competition. Kaggle with a K is a place where you could get data to play with if you want. They had the COVID data out there originally all the way back in 2020. I actually built a little Apex app that would look at all the COVID data, and I could look for symptoms myself. Then you could see some of the other ones that are out there. But machine learning, you have to look at, do I have the data? Supervised learning. Yeah, I have the data and I want to maybe identify if there's fraud based on the data I've seen in the fraud I've seen in the past. Or I have the data, I took 1,000 pictures of cats and now I want to classify if it's a cat or not, so that when I build my autonomous car, it doesn't hit the cat that's on the road. Or maybe it's regression. I want to forecast something. Maybe I don't have the data. It's just some data from big data, and I want to cluster it into age groups to do targeted marketing because I do know the age group I want to market. Or maybe it's a parking app. I want to teach an autonomous car how to park and do reinforcement learning. You got to decide which thing you want to do. You don't have to do all of them. But Exadata is your secret to everything. Use autonomous database on Exadata. I have multi-tenant, so I can put things into different tenants. I could use in-memory. Rack will make sure it's available. Active data guards, recoverable, partitioning to make it extra fast. Most of you out there probably have done partitioning. You have a trillion row table and you partition it the right way. You may be only looking at 100 rows. I also could use things like storage indexes where it's minimizing the data it's sending even before it gets to the compute side. It's doing it on the hardware side. So all kinds of advantages to this Exadata. There's also another machine learning that Oracle has, Oracle Analytics Cloud, where you can do things. This is their data visualization desktop. And you can see all kinds of different ways to graph things. I just thought I'd show this in different ways. Here's a nice graph where I'm looking at sales by different quarters, by different groups, and the width of it is profit. So it's very, very complex, but very, very, very complex of what it's showing you intuitively, but very simple to build. I also, though, can do machine learning. That's why I wanted to show it, where I could do k-means, cluster it into 5. See how easy that was. There's also things that I could do with chatbots. I could do it with, spatial data and mapping data and things like that as well are built in. And Oracle has integrated machine learning into the Oracle applications under the covers. As we move forward, though, you can see as we've gone from 16-bit with Windows 64K to 32-bit, all of a sudden 4 gig and we got the internet. Now we're moving to 64-bit, 18 with 18 zeros or 16 exabytes. I put that in miles per hour, and if Windows was 1 mile an hour, the jump we're in right now, or the jump we did when we went to the internet, was 65,000 times faster. The jump we're making right now, 300 trillion times faster. And now we're getting robotics and 3D stuff, and even 4D to some degree, but 64 and 128, it will get into 4D, we'll get into implants. 5 trillion, billions of miles per hour. How much different will things look? And here come the robots. Everybody told me they'd look like this, but they really can be unbelievably lifelike. And service robots, a little bit different, but they're there now. I can integrate those with Oracle right now. Am I doing that? Am I integrating Siri, Alexa, and Pepper the robot? Just use Oracle's virtual assistant to do that. Very simple. Might take you an afternoon to learn. When I look at Twilight Zone, there's the obsolete man. A lot of people worry that all the jobs are going away. I don't think so. I think they might go away maybe faster in some areas, and you might have to pick up faster, but there were a lot of jobs that went away in the old days. You don't want to be obsolete. And that's why I feel like you have a great skill if you're a DBA. Make sure you make your way into machine learning. But robotics and automation is going to hurt countries that aren't as developed the most. And it's going to hurt jobs that are lower level jobs the most. So keep that in mind as well. But they're here. I mean, you look at Amazon's warehouse that's constantly in motion. Different robots that are out there, and delivery jobs, obviously, as well. You can leverage database, AI, and virtual reality. I could see what's on the shelf. It would be nice if you could show people the product you have on their shelf, either with an iPad or some virtual device or augmented device. Apple, though, when I look at them, they're a tech innovator. Amazon, really a retail innovator, very innovative, but they're all about retail. I know they do a cloud, but they're more retail. Google, although I have an autonomous car too, I think they're more of a marketing innovator, and they just built a product called TensorFlow where they could look at objects, look at 1,000 pictures of cats, dogs, cars, and say, don't hit those things when you're on the car. Now, a lot of those cars use things like LiDAR as well. Hopefully they all work well. Oracle's focus, though, is different. Oracle is, I want to give you the tools. I'm going to give you either the autonomous database to do machine learning, or I'll put it in the apps for you, or I bought a company called Data Science to use open source algorithms so that you could start to move into things like robotics and speech and vision and those things and integrate that into your company. As we look forward, the trends that are out there, it used to be prescriptive analytics coming and big data coming and cloud computing. That was in 2013. And predictive analytics was here at 30% of the people. Over here is only 5% of the people are using it. And then in 2015, all of a sudden it was connected home was coming, autonomous vehicles, different types of robots were coming, augmented reality was coming, virtual reality, 5% of the people were using in 2015. In 2016, all of a sudden, brain-computer interface and quantum computing were coming, although you could see different times that they'll take to get there. 2018 is all this digital twin. A lot of security issues started happening. A connected home, mixed reality, augmented reality was almost here in 2018. 2020, though, machine learning was not even at 5% of the users. Chatbots were coming, autonomous vehicles. So machine learning is just starting. And as we get into quantum and AI generated things, Steve Wozniak said, will we be pets or mere ants? Digital transformation in the future. We're working with the hive mind right now, where you're at this remotely. It's going to be like the fever in Twilight Zone, where the guy can't stop gambling. Well, gambling is now everywhere. People are even gambling on COVID statistics. Autonomous database gives you time enough at last. Now, don't break your glasses. I guess the equivalent of that is don't lose your password. But we talked about this autonomous coming, this player piano, be careful. Let's make sure it's something very useful for people. It really helps them. We looked at ATP, ADW, some of the differences there, and how robots are going to come next. Things may come to those who wait, but only the things left by those who hustle. For a DBA, you've got to get your autonomous DBA to take care of some of those things for you so you could focus on the data side, where 80% of the work is not being done and 80% of the projects are failing. A game of pool in Twilight Zone always tells you to be good at something, you need talent, luck, work, and nerve. Make sure you work on those. Make a living by what we get. We make a life by what we give. Make sure you're always giving things. Every day you should learn something. Every day you should teach something. Every day you should give something. Every day you should receive something. Today, I think Viscosity and our other speaker, Sean Stacy and Jim, have given you things that will help you think about this. As Monica said, you could go to AuraPub and see a recording of these. Follow us online. And here's where you get a free copy. I didn't see any questions, but if you have any, you can send any. And I think we'll leave it at that and maybe put it back to Monica and say thank you all and have a great day. And thanks to those who stayed after lunch to see this session.
Thank you so much, Rich. And everyone, thank you so much for attending today. I do want to remind you of a couple things. We do have sessions like this every day through Friday. So again, today was Oracle Database and Oracle Cloud Day. Tomorrow is Oracle Database to Azure Day. We've got hopefully 2 familiar names to you. They used to be very big in the Oracle space. Kellen and Tim Gorman, they'll be speaking to us tomorrow. I'm sure you've heard a lot about Oracle and Azure partnerships. So we'll talk a lot about that tomorrow. We've got performance tuning stuff going on Thursday and PL SQL on Friday. So please, you've got to register for each stage today. And you can find info from Katie Barnes at viscosityna.com. She will email everyone, hopefully by end of today, if not tomorrow morning. So those are all my updates. Thank you to NYOUG for hosting this week. Thank you to Quest and Incorda as well for sponsoring. I hope you guys have a great rest of your day, and thanks for joining us during your hours. Take care. Thanks to all the speakers as well, Sean, Jim, and Rich. Thanks. Bye.